Okay, now the next thing I need to do is talk about something called the equilibrium law, 10.5.4. I'm sure you have seen this in chemistry before, but I'm going to discuss it here anyway. So what is an equilibrium law? Equilibrium law says that the actual concentration of reactants and product depend on the initial concentration of the reacting mixture. So basically that means is when you experiment with different initial concentrations, you will get a result with different concentrations in the final. Okay, let's write that down. In chemical reactions, the actual concentrations of reactants and products at equilibrium depend on the initial concentrations of reactants, which means the final product may be different in concentration when initial reactant concentrations are different. Does that make sense? However, all mixtures obey what are called equilibrium laws. Which says the ratios of concentrations of all products multiplied together to the concentrations of all reactants multiplied together will always give us a constant called equilibrium constant. And we call it Kg. The value of Kg depends on the reaction itself and the temperature of the mixture when equilibrium is reached. So if I was to write this combustion reaction, I was to figure out what the equilibrium law was for it, how would I do it? So I have C, what was it? CH4 plus 2O2 gives me CO2 plus 2H2O. How will I find the Kg value for this reaction? Well, Kg is found by figuring out all of the products and all of the reactants. So which are the products in this case? CO2, H2O. And what are the reactants? CH4 and O2. Now, here's where it gets interesting. I still have to worry about the coefficients. And where will these go? To the power. Because I have to do the product of everything. Guys, see how that worked? It'll make more sense. Let me do an example. But do you guys see how important balancing equations is? Okay, now let's do an example. Somebody read, please.
Calculate the equilibrium constant Kg for the reaction when sulfur dioxide reacts with the oxygen to give the sulfur trioxide, where all the reactants and the products are in their gaseous form, and the concentrations at equilibrium are found to be O2, all the good stuff.
Yeah. Okay, so how do I find these? Remember I said I have to find Kg. Can we all try to write the expression? What are all the products? And what are all the reactants? And then figure out what numbers we have to multiply them with. Chemistry people, what is M?
Moles per liter, molarity. Molarity.
Good. Without worrying too much about it, I will give you these numbers for us. Okay, everybody done? Do you get something like this? And then it's just a matter of plugging numbers in and finding the answer.